Alright, we're going to factor a difference, or learn how to factor a difference of squares in this video. So let's get started. We have a binomial x plus 4 times another binomial x minus 4. I just want to look at what we get when we multiply this kind of pair of binomials out. So if we FOIL this, we get x squared minus 4x plus 4x minus 16. Notice our middle terms are opposites, so we end up here with just x squared minus 16. We call this a difference of squares. Not sure why it went that far. Let's back this up just a little bit. Anyway, so this is a difference of squares because, first of all, the subtraction indicates that we have a difference. And squares, that's what x squared is, and 16. X squared is x times itself, and 16 is 4 times itself, or 4 squared. So if you're going to factor a difference of squares, which is what we have here, how do we go back in reverse? Well, notice with the x squared, that's just the x times itself, and the 16, that's the 4 times itself. And then we just have opposite signs. And so I think the most important thing when you're factoring differences of squares is to recognize them, because the actual factoring is pretty simple. So let's look at our perfect squares. 1 squared is 1, so 1 is considered a perfect square. So is 4. And then I would say it would be important for you to know all your perfect squares up to at least 144, which is 12 squared. So it's very important that you know your perfect squares so that you're going to recognize when you have a difference of squares. And by the way, another couple of perfect squares we might add into this, is like x squared or x to the 4th. Because both of these can be written as something times itself. X squared is x times itself, and x to the 4th power is x squared times itself. Alright, let's move on to some examples. So if I were to factor x squared minus 25, first of all, I have a difference of squares here. So we know that we're going to have an answer that's two binomials. And we know the first terms are going to multiply to x squared. I asked myself, what times itself is x squared? Of course, that would be x times x. And then I asked myself, what times itself is 25? And that would be 5, since 5 squared is 25. And then we know we'll have 1 minus and 1 plus. And that's all there is to factoring a difference of squares. Notice we're always going to have the same values here and the same values here with opposite signs. You want to remember that pattern. Let's move on to another example. So again, we have a couple of squares here. This is a difference of squares. So let's get our two binomials set up. So we know x times itself is x squared. And we've got 144, which is 12 squared, or 12 times 12, 1 minus and 1 plus. Let's move on to the next example. Now, this is another example of a difference of squares. 4x squared could be written as 2x squared. And 25y squared could be written as 5y squared. So we certainly have a difference of squares here. So let's go ahead and set up for that. So we need something times itself that multiplies to 4x squared. Well, we've already indicated that's 2x. And something times itself is 25y squared. Of course, that's the 5y. And then 1 minus and 1 plus, and we're done. And by the way, you could always FOIL this out to double check your answer, but with differences of squares, if you know the pattern, you usually don't really need to check your answer. Let's move on to the next problem. So here we have 3x squared minus 27. Now notice, even though this is two terms and we have subtraction, this is not a difference of squares because 3 is not a perfect square and neither is 27. However, we do have a GCF, so let's factor out our greatest common factor, which would be 3 here. Now notice what's inside the parentheses. Now we do have a difference of squares. So let's go ahead and go one more step. We can factor that as x times x is x squared, 3 times 3 is 9. We'll make 1 minus and 1 plus, and then don't forget about that 3 factor. We need to add that in as well. So the only difference here is we had a GCF to factor out first. So be careful, just because it looks like it might be a difference of squares, you may have some other work to do before you actually have a difference of squares to factor, like in this problem. Let's do one more example. So this time we have a difference of squares, but it's not x squared here, it's x to the 4th. But we talked about this, how x to the 4th is a perfect square. It's x squared squared. So x squared, well, we need two things that multiply to x to the 4th, or something times itself that is x to the 4th, that's x squared. And then something times itself that gives us 16, that's 4. 1 minus, 1 plus. Now, at this point, look at what we have for an answer here. This first binomial is the difference of squares, so we can actually go another step here. We get x minus 2 times x plus 2. It turns out that we can't factor a sum of squares, and so our final answer is x minus 2 times x plus 2 times x squared plus 4. So let's talk a little bit about this sum of squares issue, just to make sure we're all convinced that that's something that we can't factor. Well, let's look at x squared plus 4. Now, you might be tempted to think that it's x plus 2 times x plus 2. But if you actually FOIL that out, notice we have a middle term, which is what we normally get when we FOIL. We usually end up with a trinomial. And that's what happens here. So it might look like we might be able to factor a sum of squares, but in fact we can't. Anyway, that's the end of this video, and that'll be it.